Okay, so we've gone ahead and logged back in, and we've got our base config provides us with this port 8, which is set up just as a temporary WAN port. So our internet is now connected there, right? Actually, it doesn't look like that's flowing to the internet, which is probably a firewalling rule. But I have internet on my, yeah, see, it's showing that there's no internet access here. Not sure why, and I'm also not sure that I care. So I'm going to go ahead and just move on, right? So we've got our interfaces all set up here. Now we're going to go ahead and open up our template. So that would be the spreadsheet or the Word document, that whichever you feel more comfortable with, that you created when you were looking at the old firewall. In the event that this is a new, completely new, you won't have any of those reference documents. It would just be what you have decided to make it in talking to the customer and those kinds of things. But for this one, we have an existing firewall, so I'm going to go ahead and I'm going to make the ports match what they should. So again, this is for the city of Pleasant Ridge. This is their LAN IP address. That .1 currently is their XYWAL. So when we do the one-to-one cable swap, this will take over in the exact same role as the XYWAL, and then you won't need to change any statically set devices like printers or postage machines or NVRs, because they'll still be pointing to .1 as their gateway. So we're not doing anything crazy there, any crazy changes. The phone network is also already programmed there, and this is the proper phone network, right? They do have an all works for us. One thing to note is version 18.5.1, these ports are listed in numerical order in air quotes. So they're out of order because it's a Linux-based system and it doesn't understand that 10 is higher than 2, just because of the way it works. So these PoE ports are right up here at the front, and they really shouldn't be, right? So just be mindful of that so you don't accidentally click on port 12 thinking that it's port 2. So I'm going to go ahead and I'm going to change port 2 to their primary static for their Comcast, right? And this is all, like I said, information that was gleaned from their existing firewall. Now they only have one static IP address, so this is going to be a /30, right? So we're going to go ahead and say Comcast here, and since it's a /30, you should know that the gateway is going to be 1 digit higher than the subnet. So, and nothing else needs to be done here, so we'll go ahead and hit save, and we'll say yes, update that WAN interface. And then we'll go right through and do it again for the third interface, which is their WOW circuit. So again, port 3, kind of out of numerical order a little bit, unless you're a computer and you understand why it's doing that. Yes, it's a WAN. It's going to be statically set by WOW. On this one, WOW does their business a little bit differently. They share blocks of IPs between multiple users. So this is a /26. And we're going to go ahead and we're going to say that that's WOW. Not sure. Let me put the exclamation point in there. So the gateway is going to be a little bit different than what you would have expected because it's the /26, right? So yeah, if that doesn't make sense to you, go ahead and Wikipedia subnetting, and that'll definitely shed some light on that and put you to sleep at the same time. So now we've got both of our WAN connections configured. We've got both of our LAN connections configured. One of the things that I'll say about the LAN connection is we do need to remember to come and turn this off um, once once we're done. We'll turn this off so that because in our AllWorks deployments, the AllWorks handles doing DHCP for its subnet. Okay. One other thing to note too, because we changed this port 1, it left the DHCP server there. It just disabled it. And the reason why it does that, it didn't used to do that. This is a new feature in 18. If you would have changed the port prior to 18, this would have just been deleted. It wouldn't have stayed there at all. So every time you changed a port, even if you were just changing like the interface IP number or whatever, you would have to go in and you'd get kicked out. You wouldn't get an IP address. You'd have to go in and static yourself and then change this, right? But in this instance, it's kept it for us, just turned it off. And the reason why it turns it off is because the leases that we're trying to give out are from the old base config subnet, not the new subnet, which is fine. This is a Windows network. Windows is going to be handling DHCP for us because that's the way Windows prefers to do things. All right, so now that we've gotten our interfaces configured, right, we've got our LANs, we've got our WANs. Now we can go ahead and, based off of our deep dive that we took into their existing firewall, we can go ahead and create some hosts and service objects, right? So the first IP host we're going to create, we're actually just going to go ahead and do our normal process, right? So this is going to be done 100% of the time on every network. And we create internal _data LAN, right? And that's a network, okay? And that's going to be 192.168.146.0/24, okay? And we hit save. So the reason why we do that is when we want to create firewall rules and NAT policies, we will want to be able to reference an object like that to say, hey, anybody on the data network is allowed to go anywhere. That's not automatically done for you. It's something you need to do. And you can slice that up however you want to. And what I mean by that is because we now have these objects out there, we can make rules as specific as we want to, right? We can say, oh, the data subnet is allowed to get to this website, but the phone subnet's not allowed to. Now, we probably, for this build out, we aren't going to get that crazy, but we build these objects this way so that they're consistent across all customers, so that we know exactly which LANs and WANs we're dealing with, and we can go ahead and use those in rules to make everybody's life less complicated and more understandable. So we've gone ahead and we've done that. Normally, you would also have to create a IP host object for their phone system, right? In this case, the AllWorks address is already there because this customer has an AllWorks, so we don't have to spell that out. This data LAN is no longer in use. We should be able to delete it. We can't delete it because it's currently being used by a firewall rule. No problem. We'll just make a mental note when we go to do our cleanup that this old data LAN needs to be removed just to avoid any confusion, right? Because now we've got these new LANs that we're going to be using that fit the naming convention that we're going to be using here in 2022 and forward. We can also delete this object that comes with it. No worries. So did a little bit of cleanup. This voice LAN can be removed, and it won't let me because a firewall rule exists. So let's go in and just clean that up right now so you can see what that looks like, right? So right here, we've got our default voice policy and we've got our default network policy. So let's go ahead and go into our default voice policy, and we're going to change this to int_voicelan. So now that object is no longer in use, the one that we wanted to delete. So we can now come back to this host and objects and clean this up a little bit and say, yeah, let's go ahead and delete this because we've made it, it's the same stuff, but we've made it in the naming convention we want. And it still says that it can't be deleted. So I wonder if it's a member of a host group. So it's not a member of a host group. I have a suspicion that it will let us delete that after we remove all references to it in these different rules here, right? So these are our NAT rules that NAT our management of the all works through the main firewall, the SIP registration through the main IP of the WAN of the firewall, voice traffic through the main IP of the firewall, handset management through the main IP, reach through the main IP, buttons, BLFs through the main IP. So that's good. Then we've got our guest, and then here's the other reference to internal, or no, that's right. This is internal voice LAN. That's correct. So that's good. So it did automatically change it when we changed that linked NAT firewall rule. It did change the object there as well. It doesn't appear like there are any other references here to that, so that is good. So moving on with hosts and services. So we know also that we have an internal network on the other side of the VPN. So we're still going to call that internal, and we're going to call that internal City of Pleasant Ridge, and then we're just going to call that Rec Center, and we'll call that Rec Center LAN, right? And this is a network. Again, we're spelling it out this way so that when we're creating firewall rules and stuff, we can easily spell out that whole subnet as being allowed or denied for whatever reason, okay? We have another host object. This is not a network. This is internal building 1-PC that is statically set to this IP address. So note the difference here is we don't have to spell out a subnet because we're just talking about one IP address. So the subnet on any of these IP addresses is going to be assumed as 255.255.255.255, which means it's just this, right? So that's a host object that we're going to need to reference at some point. One of the main host objects you're going to see at almost every customer is an NVR system. So we're going to say internal NVR, and again, this isn't an entire subnet. This is one IP address. This is the statically assigned IP address of the NVR. So we're going to go ahead and set that in there. Lastly, the last host object we have is the server. And again, it's not a whole subnet. It's just one statically assigned IP address. So there are our host objects. Now, could you also create host objects for each individually statically assigned device on the network? 100% you could. And I'll go so far as to say you even should if you're thinking that you might want to manage who has access to that and who doesn't. And what do I mean by that? We have some customers who say, you know, only these 3 people can access this one printer that's in payroll, right? So that would be an instance where you would go ahead and specify the static IP address of that printer, and then you could set up a firewall rule to only allow the users you want to allow to be able to get to that device, and anyone else would be denied access to that device. So that's one example. Happens with printers a lot, where you only want certain people to be able to print to the color printer because it costs a ton of money to replace the color toner. And if you don't limit it, everyone's just going to always print in color even if they don't need to. So stuff like that. So those were the host objects that we have. Moving right along, we'll go to our service object groups, right? And obviously all of the Allworks ones are built in here. And in fact, some of these aren't actually correct, but that's okay. Like for instance, this will never work. This will never work. This will never work. These are the old Sophos way of doing things, which has changed. So these are not in use, and they won't ever work. So we'll go ahead and we'll get rid of those if we can, if it will let us. Sometimes it gives us grief. So it couldn't because it's already a member of a service group. Yeah. No. So again, when we do our cleanup, we can remove those and do it the way we want to do it, right? For this example, we're going to go back to our document that we made, and we'll go ahead and start adding our internal host objects, right? The only ones that I have spelled out are for the NVR, so we'll go ahead and we'll just get those taken care of. Now, we could follow the same configuration that we doing like internal this and those kinds of things. Sometimes that gets a little confusing. So for this one, we're just going to call it what it is, right? We're going to say it's the NVR and this is the port, right? And this kind of shows you how the Sophos is translating that, right? So it gets a request from somewhere. So let's say it gets a request from the LAN or the WAN that is referencing this port, right? So it's going to know that it's TCP, and it's going to allow whatever we're allowing to hit any source port, and then we'll translate this over to the port that we want it to be. So I know that was a lot of words and might not have made any sense, but trust me, as you do more of this, it'll begin to make more sense. So now I'm going to go ahead and do 8082, right? And you may also be asking, well, why don't you just create them all here, right? You could decide to do that. The reason why I don't is because, particularly in a case like this where there aren't a ton of ports that we're opening, for me, it's helpful to have each one of those services spelled out individually. Now, we can come in here and say add a service group, and we'll call it NVR ports. And then we can go ahead and add all of those, right? And now we can just reference that NVR ports as opposed to each individual service. But yeah, so that's my non-answer to that question that wasn't asked. So now we've got our service objects, our address objects, the replacing firewall that we did have an address group called City Hall, which had both of those subnets in it. That is a kind of an old school way of doing it. I'm not going to recreate that. The next step is firewall rules, right? So we already know that these firewall rules for the Allworks already exist, right? This is allowing anyone from Xfer coming in off of port 2, the Comcast, we're allowed to manage the Allworks on port 8443. Boom. That's a security policy that is allowed, right? So what we want to do is we want to create anyone from the outside can go and look at the NVR, right? That's the whole point of having those port forwards in the NVR. So to do this, we're going to utilize the wizard, which is a winner. We're going to choose Server Access Assistant. It's a DNAT rule. We're going to say OK. So specify the private IP address of the server that you want to use. So that's the NVR, and we hit Next. Select the public address for which the users can access the server. Well, we're going to have them come in on port 2 of the Comcast. Okay. What services can they access? So here we have our group, and it will also show each individual one. But since we know we added them to this group, and you can highlight over here and it shows them all, we're just going to add the group. So this is the ports that we're allowing to be hit. Since we don't know Jim Bruckman's home IP address, and that might change, or Amy's home IP address, or the police sergeant's home IP addresses, we're going to allow anybody to sniff and hit those ports. We're relying on the security of the NVR itself to manage what users gain access to that NVR system or not. Is this ideal? No. Should we mention that? Probably. But this is the way how it's set up today, and we don't have the information to make it more specific, so we'll leave it to any. So and here's what the firewall wizard is going to tell you. It's going to say, okay, so I've got this. I'm going to set all this up, and I'm going to create these NAT rules. So I'm going to allow traffic to do what you asked it to do. I'm going to masquerade that NVR with the public IP address. So understand what that means. When the NVR goes out to the internet, it's going to present to the internet the public IP of the Comcast cable modem, right? Which is fine. That's exactly what we want it to do. And then it's going to take it one step further and say, if somebody inside the organization tries to go to the NVR using the public IP address, we're going to go ahead and we're going to allow that pinhole to happen, okay? So that's what that does. So we'll go ahead and save and finish. And then there's two key important things you need to do when you create a firewall rule and the NAT rules using the wizard. One, open it back up, change the name to something that makes sense, right? Because if you've got 10 lines of just this random stuff that was created, it can be daunting for help desk staff to understand what that means, right? So for this one, we're going to say allow underscore WAN underscore to internal NVR, right? And then the second, so we named it something that makes sense. The second important thing we want to do is we want to log firewall traffic. I've already put in a feature request to have them change the wizard so that any rule you create using the wizard will automatically check that box, because in my mind, there's absolutely no point of having a firewall rule without logging what that rule is doing, because you'll never be able to diagnose any kind of problems, right? We'll go ahead and we'll save those quick changes that we made. Now, here's a decision-making point. It created it at the top of the rule set. And remember, your security policies are done top down. So is there a problem with that? For this, no, there isn't an issue with that. It would cause us issues if there was something else we wanted to process before that. But for this particular case, there really isn't. We're going to be getting more into grouping firewall rules in another video. But like for this is an inbound rule and this is an inbound rule, we could group these two rules together and keep them at the top. Where this traversal rule, well, this traversal rule is really inside, right? It's land to land, you know? So that's a different kind of rule. So there, we've added our networks on our network ports. We've added our host objects for both IPs, addresses, for IP subnets, for services, and for service groups. We've created a security policy using the DNAT rule wizard to create that. And we've adjusted that to loggings and to the name of it to make sense in English. Yeah, so I think this is a good place to stop. The next video is going to cover creating the VPN structure and making sure that the firewall rules do exactly what we want them to do. Yeah, so thanks for hanging out. Thanks for watching this video.